Good morning. My first project is a power supply, a contained power supply for the treadmill motors I'm using for both my lathe and my bandsaw. I switched over to treadmill motors, excuse me, because they are, for their size, a very high horsepower. This one is 2.5 horsepower. It runs on DC voltage, so you need something to convert AC to DC, and it is a variable speed. So originally I was using the boards that came out of the treadmill, and that is the power supply and the controller board. And what's nice about these is they use pulse width modulation to control the speed. So let me draw that out for you. Instead of, with pulse width modulation, you send pulses to the motor like this. So the pulse would be, for this motor, is 80 volts DC. So if you want it to go faster, you send more pulses to it. What's nice about that is because it is at 80 volts, you are getting maximum horsepower out of this, even at slower speeds. So, unfortunately, both these boards, well, the power supply board is good, but the controller board is bad. Unfortunately, I have another one, but that one's bad as well. So I can't use that anymore as an option. What was cool about that, though, is I was using an ESP32, which is a microcontroller, to do the pulse width modulation, and have a display in the box which would show me the actual RPMs and the pulse width modulation speed. So I have to put that away. I might be able to fix that board. I don't know. I have to look at it. It's kind of tricky. I'm not sure I have the right type of oscilloscope to fix all the parts, or to find out where the parts might be bad. And in fact, I see a little piece of stray solder in the board, so that might be what's causing it to not work right. I will have to check into that. So this right here is a varistor. Now what that does is changes the amount of voltage going to the motor to control the speed. So like at slow speed it'll be 20 volts, and then you can turn it up to higher voltages. The downside of that is at the slower speeds you don't have maximum horsepower because you're reducing the amount of electricity going to it. What I have also done with this is put in a bank of relays so that I can reverse the direction of my motor. That's something DC motors can do. AC motors typically can't go in reverse. You can, but the motor has to be designed for that. DC motor, you're just switching the direction of the voltage. So I'm still going to use my ESP32 microcontroller, but I'm hooking up over here, my desk is a little messy. That is a magnetic sensor, so I will put that near the main pulley, the drive pulley on my lathe, and I'll also have one on my bandsaw. And then on that pulley we'll have a little magnet, so every time that magnet goes through I get a pulse on my Arduino and I can calculate the RPMs, so I can tell how fast it's going. I am not ready to turn this on yet. I still have some wiring to do and we'll clean up, but it is almost done, and I'll be able to mount it on either tool when I'm using it. I did have them hooked up externally, but I didn't like the dust getting on the components. I also didn't like that it was a potential shock hazard. AC voltage can be dangerous, but high voltage DC is even much more dangerous. So I don't like playing around with this. That's why I wanted to put it in a box and make it, something that I don't have to open. I have a connector on the back here to plug into the motor, so it's just plug and play. And I will have more on this later. I just wanted to give you a quick introduction on what I'm doing right now. I do have two other projects on my table right now. I have a 3M dust mask, so that when I'm doing woodworking and sanding and stuff, I don't breathe in a lot of dust, but it never really fit quite right. So I hooked it up to my CPAP, an old CPAP that I have, which blows air into the mask, so I get fresh air coming in from outside, which is also filtered with the HEPA filter. And it creates a positive airflow, so I'm not getting dust into my lungs. Problem with that is I have to have a 20-foot hose connected to it, and I have to drag that around with me. I don't like that. So I am actually looking at making a positive airflow with some little fans. It will not be outside air going in, but I will filter it. That might work. I just have to play around with it and see if it does. The other project I have, which is over on the far side you can't see, which this is the main component of it, is a remote rocket test stand, or launch stand. So it will actually wirelessly connect to a little box at the bottom of the rocket launch stand, and it'll control when you actually ignite the rocket. It will also record the amount of thrust coming from the rocket motor. So more on that later, but that is another one that I'm working on. I was trying to get this done first so I can work on this one, but there's always many projects. So great thing about these is you go on Facebook Marketplace and you can pick up a free treadmill. Chances are one of these boards doesn't work, or there's some other issue, but if you strip out the DC motor, you can use it. And these things are awesome. They got lots of power. Safety issue, or safety concern is high DC voltage. You gotta be careful of that. And because they have so much torque, you gotta mount them really well, or they can rip right off your mounts. So always be cautious of safety issues, and always be wary of, voltages like this. These can be, I know I don't have it plugged in, these will be live 80 volts DC, so I don't want to touch these. I'm going to put a cover over them, and everything else that is high voltage I have covered up, with the exception of a one-off switch back here, which I'll cover that up too. So that's it for now. Good luck. Have a good day.